I think this is a good follow-up for the last talk, because
Yes.
we're definitely going to take a practical approach and look and especially with the growth of microservices over the past 4 or 5 years and becoming more of an accepted architectural style with trade-offs, how you've seen kind of a reemergence of DDD. It's kind of become popular again. In fact, they're even having big conferences and other things. Mostly I've seen because of microservices. And so we're not here to really tell you all the details about DDD or all the other stuff. We want to pull the main concepts of DDD and from a practical experience how it works with microservices. And just for a little bit of background, I just want to say I'm more familiar with that book on the left, the blue book from Eric Evans. I actually was a reviewer from the software architect group at the University of Illinois at the time. He wrote it as a patterns book originally, Eric Evans, and he used our group to review it a lot. And then I'm also involved with a lot of the pattern conferences that we have. And he submitted it there, and we gave him, a lot of us from industry, like even Ralph Johnson, Martin Fowler, and other people gave him a lot of feedback as we were going through that. And it was a really good thing conceptually when you were looking at object design of how to do good domain modeling. And it was really taking Eric took a lot of things that were known out there from domain modeling and put it together in what I would call, well, the blue book. But to really learn it, you might have to think from other perspectives.
So the blue book was published in 2003. A lot of people got interested in DDD, started using it. Now, for the people here who is willing to learn DDD, we'd suggest looking at these other 2 books or maybe some other book. So the second one, the red book there, is by Von Vernon. Vernon was at SATURN last year, giving a talk, by the way. And then there's the other book by Scott Millett. These books were published more recently, and they build on practical experience of the authors and the community. So they are actually better source for people who want to learn and use DDD.
Right. In fact, that almost related to like the original design patterns book had a lot of good stuff, but it was very hard to learn design patterns from. Looking at some of the follow-up work made it easier. Same thing here, but there's still a lot of good stuff in that one, but I would concur with what's going on. So we really want to look at, we're not going to look at all the concepts of DDD. DDD had a lot. I'm even happy, hey, look here, big balls of mud. He even mentioned big balls of mud as part of one of the concepts with this thing. But there's really some main concepts that we've seen that have become very useful to help when you're dealing with your microservices. And we want to at least outline what those are and talk about how, and with an example of how they can map into microservices. And the main ones will be like the domain, also things like with aggregates, with entities, value objects, and your aggregate root. Your bounded context that we heard a lot about in the last talk, any of you that were here for the last talk, that's a key concept. The ubiquitous language, that's also a very powerful thing, and in fact, that's one of the things that I find very unique anytime you're doing domain modeling, is having that common language and domain event. And just to kind of start motivating it, we'll go talk about a domain model. And when you really look at the domain models within DDD, it talks about domain. You can even think of like a component has subcomponents. Like domains can have subdomains. And here, let's take like a traffic ticket domain. Let's imagine we're writing a software system here in Pittsburgh.
Springfield.
Springfield. That's the city almost anywhere in the U.S., thank you. But we want to do something for Springfield, and we want to write a system for that. And so one way you could think of breaking down the domain for the traffic domain for Springfield is you can think, well, maybe we have things like drivers, the violations of the actual different possible type of tickets that you could have, and then maybe vehicles and registrations. And you could possibly even break it down even other different ways, but this is kind of one way of breaking down the domain within subdomains. And so within DDD, they talk about having you have this domain and how to break it down within subdomains. And then also they have this concept of within your subdomains, you have this concept of entities and value objects. And obviously this goes back to even the old object-oriented days of what entities are. You can even think of like your classes or your different types of objects. And they have an ID and life cycle. They have definitely behavior. And it's not like the dumb data objects, you know, the simple type of whatever. They're really smart objects. They really have not only values, but behavior with it. You can think about drivers and customers and order payment. And then another concept in DDD that Eric picked up from the 90s as well that he included in there, this concept of value objects. And value objects are really like smart attributes. That's what me and Brian Foote were calling them kind of in the 90s before Eric Evans. But I mean, value objects have been around for a while, but you can think of things like address. Well, even you think of integers had different behavior things on it. So you don't do a value as just a string and you parse and stuff like that. You might have a geolocation with this, or you can even think of like weight, and weight is it in pounds, or we want to convert to grams, but those values are really more these immutable type things, but with behavior with it, and it's not just data, it's really the value that you're holding on to.
Then we have the notion of an aggregate, which is a cohesive business concept that typically consists of one entity, maybe two, maybe three entities, but it's a small cluster of entities that are closely or logically associated, right? And for example, a vehicle can be an aggregate, and an aggregate has at least one entity that is the aggregate root. So accessing data or behavior in that aggregate has to go through the aggregate root. So on the right we see a couple of examples of aggregates. The one on top has vehicle, and vehicle has a VO license plate. And so what we have as an aggregate is a small set of entities that are tightly connected logically. They have cohesion, all right? An important concept coming from DDD is that within an aggregate, we have transactional consistency. So when you issue an operation on an aggregate through some interface that is available through the aggregate root, that operation may change data in one entity, maybe two entities, etc. But one thing you should have for sure in your solution, transactional consistency in that data change, okay? So it means when you're loading an aggregate, you load all the entities, and then you do data changes, and at the end you commit work.
Yeah, but what about if my operation requires updating multiple aggregates? So aggregates are kind of like the API into your interface from the root, is what you're saying. But what do I have to do if I'm going through multiple?
We're going to have to leave that question hanging for the moment, but we're going to get to that, Joe and Peter Parker.
Okay. Okay. My spider sense is up. Okay.
Okay. So, and there's another important concept that we just want to set the grounds for, because we're going to build on top of these things, right? Is the notion of a domain event. And these days with microservices, we talk about event-driven communication, event-driven architectures. In DDD, we have that notion of communication via events, a core part of your domain layer. So in your domain, you have the notion of domain event, which is something that has happened to an aggregate. Okay, and here's some examples. You say, in our running example, traffic ticket issued is an event. Traffic ticket paid could be an event. Driver created can be an event. And in practice, you're going to model them as classes. They're typically organized in a hierarchy. So you have traffic events and then the subtypes, all right? And they will be used for communication, of course, as we're going to see later.
So let's talk about bounded context a little bit. We heard some before about, do I have the right bounded context, or do I refactor, and maybe we can deal with some technical debt with that. But really, with the bounded context, we're really looking at the scope of a domain model. So really the scope of the bounded context could be the entire domain model of a subdomain, and so it depends on how you break things down within your domain modeling and within your subdomain. And so you're kind of breaking the context. So often if you look at legacy systems, you might see multiple domains within that bounded context. You have things kind of coupled, and maybe it's starting a little bit too big, but maybe as you're dealing with technical debt, you can evolve that. And in practice, it's also, the scope of it's more around a traditional, what you say, an application system. And one of the important things is thinking about when we're when you're thinking even from DDD outside of microservices, and we'll see later how this applies to microservices, is figuring out what's in your bounded context can be very useful for making decisions as you're designing things. And actually it can help minimize some technical debt and minimize some of the other types of problems that might come up, because it helps with good design so you won't have as much refactoring and other types of issues later on as you're going with this. And another thing that's very key here is a concept, just to kind of finish up the main concepts before we get into our examples, is this concept of ubiquitous language. Originally, I've been doing a lot of work, and even more recently here with Paulo, where we're doing a lot of microservices over the past 4 to 5 years. And using this domain modeling concept is key, but part of that is coming up with that common language. And when you really look at what Eric Evans says here, and I know there's a lot of words in here, but he really talks about the ubiquitous language being this common, rigorous language that between the developers and the business experts. And really, when we want to focus around, because we can name things whatever we want, but I want to be able to name it around the business domain and work with the domain experts. And especially if I bring somebody new in, it'll map closer to the domain, and it'll help even validate the domain. Even as we're testing, we're kind of speaking the domain language. And in fact, here it says, I like this quote by Eric, domain experts should object to terms or structures that are awkward or inadequate to convey domain understanding. Developers should watch for this problem that will trip up the design. So the closer I can map to the domain experts, the better job I can do. So within language, within the bounded context, I want to be using that domain language, not whatever our language, our tech jargon or whatever it is. We need to try to map to that business domain language the best we can. And so just to kind of give an example, and we'll get into the details here, is how this maps in. You can think of our original example. We could break down the different drivers bounded context based upon those subdomains. And then we have the violations bounded context and the vehicles and registration bounded context. Here we had, you can probably, there's a lot more details that you could probably get into here. We're just giving a high level picture from this. Is the one aggregate group is drivers. Drivers have addresses and licenses, which happen to be an entity as well. So both driver and the licenses are entities. And then you have traffic tickets, which, they have the vehicle. Notice here, traffic vehicle is a VO here, but it's an aggregate root, it's an entity over here. Whereas over here, it could be that when they took a picture, and we haven't really mapped it to the exact vehicle yet, it might be mapped to ultimately a vehicle, but at this point, it's just a value of something that we've got. Whereas in this bounded context, vehicle has a little bit of a different meaning. It's the real vehicle that I'm registering my car. And notice that when I'm driving a car, I might be driving your car, you've loaned me your car, so I'm not necessarily the owner. The owner could be quite different than the driver associated with that. But this is kind of an example, and let's take this example and look at how we might be able to map this.
So one thing that I want to say
to microservices
is that we're not trying to explain DDD for you.
Not in
we're
detail,
setting
no.
the ground, and the basic idea is that you're going to have these small clusters of entities. They form the aggregates. And there's something bigger, which is the bounded context, which is the automation of a subdomain. And this, of course, is an oversimplification of this example so that it fits in a slide, right? And you see that within a bounded context, we have one or more aggregates. You have a few aggregates. So there's entity, something bigger is the aggregate, right? And something bigger with several aggregates is a bounded context. So this is the DDD discussion. We didn't touch microservices yet.
Right. And in fact, there's even one bigger context, which we have multiple of these bounded contexts, which is part subdomains, which are part of the bigger domain, even from that.
So how do we go from domain models, that's what we've been doing so far in the slides, to microservices? Well, before we get there, we need to go back to what a microservice is. And there are a lot of definitions out there, and here's one by James Lewis. And this is a picture. James Lewis came to SATURN last year, gave a talk about microservices, very interesting talk. It's on YouTube, worth watching. And they say, this is him and Martin Fowler, they say that microservices is an architecture style where you build an application, a suite of small services, each one running in its own process, and they communicate using lightweight mechanisms, typically a resource API, say a REST API, But importantly, they say, well, they are built around business capabilities and they are independently deployable using
Yeah.
fully automated
Notice those
machinery.
words, the important words that I heard there that Paulo said was these small, lightweight, communicating with these lightweight mechanisms and independently deployable were key kind of concepts to that architectural style.
Well, when we, in our organization, when we tried to use microservices, there was a lot of confusion despite the definitions out there. So we were discussing this, and one thing that we did, I myself took on the job of writing a blog post for the SATURN blog, and over there we tried to define microservices. And one thing that has been established, at least in my mind, is that microservices have a clear distinguishing factor as an architecture constraint. And we know architectural styles have constraints. And for microservices, we can say that a microservice should contain a single service or a small set of cohesive services. So that is a question, it's an important constraint because a lot of people ask the question, so is this a service, this is a microservice? It's not clear, right? But, okay, this is all concept yet. What is a microservice in practice? Before we get there, let's look at services. Well, if we want to show something in practice, we need to look at how it's implemented. So we're going to get down to a little bit of code and technology specific solution here, but this is an example, okay? So the example I'm going to use is of a REST service. It could be a service, a gRPC service. It could be a service consuming Kafka topic like a Kafka listener, but let's pick REST for the moment. And I'm going to pick one technology of implementation for REST services, specifically Spring Framework. Pick a REST service implemented using Spring MVC, okay? So here's an example of a REST service. So this could be like a backend service in our Springfield traffic automation. And you have there a REST controller. So it is traffic ticket controller. That annotation REST controller tells me that this is a REST service. So we can say this is a REST service. And there we can see two endpoints. So there is a post endpoint, this post mapping there. There's a put endpoint, HP endpoint. So this is a service with two endpoints. So this is a service, a REST service in particular. Here's another example of, again, a REST service. This one is vehicle controller, also a REST controller annotation you see there. There's a post mapping endpoint. There's a get endpoint. So again, a REST service. So we have two REST services that we just saw.
So are these microservices? Question to you.
It depends.
All right, good
So,
answer.
and-
The typical consultant, it depends.
Going back to our design constraint, and so I got this question a couple years ago. I was teaching microservice design in Mexico, and someone said, hey, they were using Spring Boot, and they said, hey, if I'm looking at a REST controller class implementation, how can I tell whether this is a microservice or not? I know it's a REST service, right? Well, you need to ask. It depends on how it's deployed.
Independently deployed. Remember, that was one of the definitions.
So remember, it's a single deployment unit. A microservice contains a single server or a small set of cohesive service. So we need to look beyond the code. And here's a snapshot of the IDE. And you see the packages up there. If you were guessing, this was Kotlin code that I just showed you. And there's a sub-package application for application services, domain layer, infrastructure, and then there's a REST folder, typically where you would have your REST classes, REST controller classes. So you see those two classes over there. So this is a microservice with two services.
Since we're seeing the Docker file, we're seeing that these are contained.
How do you know this is a single deployment unit? Well, there is a Docker file there. It means it's built as a Docker image, right? That's a single deployment artifact. There's build.gradle there. So, but in practice, by seeing that Docker file, I know these two services are packaged together as a single deployment unit. That makes them, so two services in this particular case, one microservice.
So what about the size? I mean, as you know, if it's too large, we might have the challenges of like microliths or the mini monoliths or whatever with that. If it's too small, you know, we'll have the challenges of it can become very chatty. I mean, I could make every function a microservice, right? If I push the extreme that far, but that doesn't make sense either. So it's good to kind of think about that because there's data challenges. If it's too small, we're going across many microservices, and we'll have the distributed transactions or distributed. Now we've got a big distributed database type.
That's
issues.
a killer.
Yeah, and so how can we use DDD to help us deal with some of these issues? One of the things that we want to look at is not only for the size. DDD can help with the size, but it can also help around with the bounded context. But it can also help with some of the other potential entanglements, with some of the other issues to help minimize some of the refactoring. One thing I will say about on size, which is one thing I liked about the previous talk, is I tend to err, if I'm going to err on being a little bit bigger than too small, and then you can do the refactoring from that, because trying to deal with too much chattiness and performance and other issues can become a problem. So if you start off, one of the early things about strangling a monolith might be starting out with a component that's more like a macro service, but you get it out there going, and then you figure out, now we've at least pulled that away from the monolith, now we can figure out some better ways to even start partitioning that down into getting into the right bounded context. So we want to start with one example here. We have multiple scenarios. So our first scenario one is, so maybe the data changing operations affect only a single aggregate. And in this case, what you can do is use one aggregate for one service. That's typically how you want to do your aggregates. For every aggregate, have a service. And your aggregates might have multiple entities, and you might have multiple VOs and stuff, as was pointed out earlier. And then for one service, one microservice in this example. So, and look at our example here with scenario one with the violations. We could map this violations down with the traffic ticket, with the ticket being issued, and the location and vehicle, is we can have a single microservice for the traffic ticket, a single service, which is a violations microservice, part of it, the service, traffic ticket service is part of that, but that's a single service that we've mapped up into here. And notice for traffic ticket issues is some kind of event that other people, that we're doing a publish subscribe, where we can put the event, using event-driven architecture, publish that out there, and anybody interested in that could
So in this
take
example,
notice.
we're sticking with the Spring Boot framework as technology of implementation, but this is a possible
Right.
example. In this
Right.
case, this could be a Docker
Whatever,
image,
yes.
and that circle would be our REST service,
Yes.
right? That has functionality for that aggregate. So there would be endpoints for the operations within that single aggregate. So you would have a single aggregate, a single REST service in this case, packaged in a single Docker image. That means a single deployment unit. In particular, as Joe pointed out, this service happens to send events that we're going to use later on.
However, my spider sense is coming up a little bit still. What if I have to be updating multiple aggregates? And
Yes, so
what do we need to do there? Maybe you can explain kind of some different scenarios from that.
remember we said that within an aggregate we have transactional consistency. So in the scenario number one, which was the simplest, we're good with respect to changing data. An operation will only touch the entities within that aggregate. They're all within the same REST service, a single service, that we're good. Now, sometimes operations that you call on the system need to touch multiple aggregates. And in that case, we get to scenario number two. Well, what do we do then? We still keep the scope of a service is the scope of an aggregate. But now we have multiple aggregates, and then we're going to have multiple services. Let's assume for the moment within scenario number two that these aggregates fall within the same bounded context. So they're still part of the same bounded context.
Which is an important point right there that you just made, is these aggregates are still part of that same bounded context.
What we could do is to use that notion as our cohesion ruler. Remember we said that a microservice contains it's a deployment unit that contains a single service or a small set of cohesive services. Well, now the bounded context is the cohesion ruler. So we get these services, it's one service per aggregate, but we're going to put them together and package them as a single microservice. So this could be a Docker image that contains, say, 3 services like that. Or if we look at an example, in this case, we had the vehicles and registration. There are 2 aggregates there. One is vehicle and the other is certificate of title. We could implement that as a couple of REST services. That's what we need for this kind of functionality. Each one will expose different endpoints, right? Different operations, but one or other operation will need to touch the other aggregate. And in that case, DDD gives us a modeling, a domain model element called the domain service. So for domain logic that crosses the aggregate or the entity's frontier, we can create domain services and model them as part of the set of classes that you implement, and you're still within the microservice. You don't need database distributed transactions, for example. So you're still good.
So you can still be safe with that.
Exactly.
But what if what if I needed to go across multiple bounded contexts? What about that scenario? I mean, this works well if you have, within that bounded context, we have multiple, and we can be very safe. And in a lot of times what we say is, one of the patterns is a database per microservice, so you may not do that. In this example, you were kind of looking at that, and you had transactional consistency there. But what if I need to go across multiple bounded contexts? What should I do then with microservices?
That brings us to scenario number 3. Here we have still one bounded context corresponds to one microservice, but there's some operation that needs to go interact one BC to the other. For that, we can use events. We can use domain events.
Event-driven architecture.
Exactly.
Okay.
So we're going to need a sort of message broker product like one of the ones we listed here as an example. And as a matter of fact,
and there's many out there. Usually you don't write these. You don't invent. You can write them, but why not use what's already out there?
You choose one.
Like
In
Kafka,
our organization,
Rabbit.
we have used some of the MQ old products.
We're using Kafka and Rabbit and stuff with...
Right, and Kafka as an example. So here's scenario number 3. We talked about the other 2 BCs already, but this is drivers. And here's what happens with drivers. It has functionality to update the drivers and issue commands that will touch driver aggregate alone. But sometimes when a traffic is issued or a traffic is confirmed in the other BC, what happens? Points are assigned to a driver. Well, that's creating a traffic ticket. That's an operation that belongs to this other BC that we already saw, and it issues an event. This event will cause a data change here in drivers. So what we do...
Yeah, suspend my license or whatever.
Add points to your...
So for insurance.
You have a single microservice, driver MS. It contains a REST service, that's driver, right, with endpoints to renew a driver's license, issue a driver's license, and so on. But it has Kafka, in this case we're picking on Kafka listener component, which is another kind of service, different from an HTTP REST service. It subscribes to a specific Kafka topic and will listen to those messages, but it's another service, and you will get those events from the other BC. So we have this interaction crossing the BC boundary, basically going from one microservice to another using events. And when you do that, what you can create when you're changing data in one place, then changing data in another place or a third place, 3 different microservices, to deal with atomicity, at the end, you want all the data changes to be done or none, you can implement an event-driven kind of saga.
So we can use the saga pattern, a well-known pattern that's been talked about, especially with microservices. Even Chris Richardson has put this out recently.
Yes, and in fact, the talk that Chris Richardson was at SATURN last year, and he gave a talk about event-based sagas. And well, we're not going to explain everything, but this is a simple example. And imagine, actually this is a slightly different event. So let's say there's a post operation that is called to pay a traffic ticket. That goes to traffic ticket service over there. Now traffic ticket will change its local database using its own database connection. you will send then an event. That event is traffic ticket paid. It goes through an event bus, there's some sort of topic there, and then it goes to the subscribers. In this case, there's a payment service, likely a separate BC altogether.
Separate microservice. In this
different
case, the
microservice.
circles are being illustrated as a microservice in this example.
And payment will then make some data changes to some payment database, and at the end, we'll send an event, payment confirmed, all right? Look, traffic ticket is a subscriber of the second event. When it gets that event, it knows the second step, which was the payment, is complete. So it will, at that point, effect the change that it made originally. So the ticket's now confirmed. So this is the kind of happy path.
Let me just add one thing here. One nice thing about this kind of decision, if you've made this separation and you've seen this using this good publish subscribe, is we've been able to do some separations of concern. And so it's not only giving you the benefit of getting the right size service, but we've also kept, we've decoupled things. We could have maybe an SMS or other types of messaging things that we want to add here, and it just subscribes. You no longer have the entanglement between traffic ticket or payment. So it's helped with some other kind of muddy type issues. It could also help with keeping things clean as you go as well from that good design principles. So using good design as you're doing microservices, as was mentioned even earlier with technical debt, is still important. That was something they learned, is maybe we should have still kind of applied some of that. So that's what's happening here with this. So you get more benefits than just the size. Yeah. There's other good things going on here with this scenario.
There are modifiability benefits. They're coming, we say they become loosely coupled. So because senders don't know about the receivers don't know about the senders. Also, it's easy to add or remove logic, right? So these are modifiability benefits of this event-driven communication. Another benefit with respect to dealing with the database transaction is now these data changes are local transactions. There's no need for some sort of two-phase commit kind of distributed transaction, which we know doesn't work for microservices.
In fact, Chris Richardson said, don't do that last year.
With a Saga, what happens if there's a problem, and this is the situation when the payment, if you follow the flow there, you're going to see that payment didn't get authorized. So payment fails. And then the payment service or separate microservice will issue another event, which is payment denied. So step one of the Saga was processing the traffic ticket. It is a subscriber of payment OK event, but it's also a subscriber of payment denied. So in that case, when it gets that kind of failure event, it will trigger the undo operation corresponding to the first step. So it will undo the data changes to the traffic ticket.
So just any kind of architectural decisions, any kind of design, there's always trade-offs. There's benefits, but there's costs. I mean, anything complicated, otherwise we just always do this. But so it's even like doing some of the separation with the event-driven. As we talked about before, you have the maintainability with the loosely coupled, possibly with scalability and throughput. What if we need to scale up? We have part of the component out on the cloud. We can scale up that part easier without messing with the other part. The availability and reliability is a potential benefit, but there are costs with this as well, challenges.
So maintainability is a challenge. It's a benefit, but it's also a challenge because when you're communicating through events, you're introducing concurrency, right? So this kind of programming model is far more complex. Every event that you send, you don't know when it's going to be processed and whether it's going to fail. If you compare with the traditional request-response approach, you send a request, I mean, the caller will get a response and we'll know if it worked or not. Now you send an event, you need to expect all possible situations where it's confirmed, it's successful, or it's not. So you need undo events, correction events. You may need synchronization events.
So this extra layer made it more maintainable in a way, but we've also added this extra layer. So that's some complexity. And the testability part can become more challenging because of that as well.
And interoperability and portability is a bit of an issue in general because you're going to pick one of these event managers, event bus products, message brokers, and they cause some sort of vendor lock-in. Though most of these products these days, like Kafka or Rabbit, they are polyglot. You can use multiple programming languages.
We're using whatever with it. And then also UX can be very challenging as well. But you can even think like if I'm doing an ordering system, or even when I get my airline ticket, it follows something similar to what Paulo was going through the scenario example before, whereas it's still processing my credit card, so it says, okay, we're processing, but trying to come up with a good UX, user experience, is a little more challenging.
So despite these challenges, for microservices these days, we have observed that the benefits in general, in many cases, they were going to
far outweigh the cost.
The cost.
But you still need to consider that, because if you do need consistency, which sometimes, like maybe we're moving money from my bank account to your bank account, we don't want that to go wrong, so we may have to somehow wrap that up in a certain way to ensure consistency. Maybe we have to put a bounded context around that.
And we were looking at that sequence diagram. We probably saw, you guys were imagining, oh yeah, but you're making some data changes, then you need to undo things, but what if some other user has already operated on that data? So there is a risk of inconsistency.
Right.
We're trading transactional consistency, which you still get when it's an operation that touches a single BC, but we're trading that for eventual consistency.
Right.
But it turns out...
So do you need extra logging or whatever else you need to do?
We can say it is
the logical
choice
in general.
Many
so
cases.
Most of the time, most cases, you see this a lot with microservices. So let's just wrap up. A few takeaways we're hoping that you get out of this today is, one is we're hoping that you can at least see DDD, or domain-driven design, or at least good domain modeling, the concepts of domain modeling even from before DDD, which DDD was outlining, can be very useful. And there was a lot of good concepts such as bounded context, aggregate, and entities that could really help when you're designing your microservices. And
so you can model a service corresponding to an aggregate, one service. That's a simple rule that you can try to follow. Multiple aggregates can still be part of the single microservice, all right? And then for communication across microservices, meaning a communication across bounded contexts, you can try to use events.
And then finally, I don't care whether you use DDD or not, or whether you're creating microservices or not. It's all about trying to do the right thing, is model around the business capabilities of the domain. To me, that's one of probably the most valuable things I learned back in my young programmer Joe days, when I was hacking back whenever in the 90s, or learning all this stuff, is we learned about doing the domain modeling around whatever that business domain or whatever your domain is from that. And you can use a lot of these concepts from DDD. You don't need to use all of DDD, but these concepts can help you with modeling around the domain, and such as the entities, aggregates, bounded context, and the ubiquitous language. And just to kind of put a plug in for 515 is, we're going to talk kind of further. We got our ideals, the core ideals for microservices design, which kind of relates to this, which is our funny acronym, which we'll explain at 515. So thank you very much, and we hope you enjoyed it, and hope you get some value out of it.
Thank you very much for the talk. I thought it was really interesting. Now, I have one question, and in my experience, sometimes it's difficult to have the domain model well established initially, and as the system evolves and new features are requested,
yes,
new entities need to be added and
yes,
new relationships. And I was wondering, so for example, if you aggregate two entities together, and then later on you need to disaggregate or add new aggregations, so how do you deal with the evolution of the domain model? That's kind of my question. And
how I think of it is, it's just how we would deal with it before, except here we're looking at, it's still modeling around the domain. So as changes come, you may have to refactor, we may have to separate, we may even have to split up a bounded context, for example, and some of the refactoring type things that were talked about. You'll still have technical debt coming up, because we're still evolving and changing, and especially if our business is evolving rapidly. If it's not, then maybe we can get the perfect model, which I doubt. as we go. But in general, all the good principles that we should still apply. So as we learn new things, sometimes we might do the most expeditious thing because we have to release it, just as was pointed out before. We got to get it out there, right? And so we do that because we have to. It's a business. Sometimes technical debt makes sense from a business decision, but ultimately we don't want to let it get out of hand. So we may have to refactor and split things out. So we can use all those good principles, but we can think, if we're thinking about the domain, we can let the domain modeling tell us how we should split those aggregates and how that domain or that bounded context should evolve as we go.
For things that are modeled and then implemented and made visible, accessible as a service, say REST services or listeners of subscribers, there's also an important requirement to keep the contract
Yes.
compatible with what's already in production.
Right.
So, and there are some patterns that you can employ to deal with the changing implementation logic and the changes in the domain and still preserving the contract. So
Right,
things
for
like
patterns
using
like
a
proxy,
facade or
facade,
API gateway and so on.
API gateway, BFFs, things like that. Back end for front ends, not best friends forever. But, okay.
One more question.
Over here, there's
Really?
a couple.
Ah, there.
Okay.
I think he raised his hand first.
Okay.
I have a very simple question. Who owns the domain model?
Well, and that it depends. We'll use a typical "it depends" type answer, but at least for the large changing organization that I'm working with right now, which is a very successful company in Brazil in the financial domain, and even in a down economy, they continue to grow very rapidly, and they went from 20-some teams 4 years ago to 150 teams. They let the domain model is owned by the teams as that team evolves within it. So the teams themselves are kind of figuring out and working on the bounded context and from that. Now you might have something bigger, and so there might be multiple teams that have to communicate through some of the different types of services working with that.
For Greenfield, the approach that we just showed will kind of drive you to smaller domain models. That
Yes.
means smaller
Yes.
BCs. That makes things easier because each microservice is a small software project. So there's a custodianship for that microservice. That means there's custodianship for that BC and hence its domain model. So it helps in that
Right.
sense as well.
And one thing that we're not talking about here that we're sweeping under the rug is there's still a lot of complexity. Well, now we build a distributed architecture with distributed databases, and you might have many microservices communicating with, so you have to still manage that complexity, which we haven't talked about. But if you've done a good job with your domain modeling, hopefully you've minimized some of that with the EDAs, and you're getting the right size and things along that lines, so it can help with that.
So Phil wanted to ask, where is Hulk?
You had a plant. I see.
Paulo always has a plan.
Yeah, break
Thank-
the monolith. Okay.
Thank you very much.